Okay, so on page 194, you can see problem 11. So it says a bacteria culture is started with 300 bacteria. After 4 hours, the population has grown to 500 bacteria. Okay. If the population grows exponentially, so it's saying that it's growing exponentially, we are asked to find, okay, first of all, we want to write the recursive formula, then the explicit formula, and then we want to find how many bacteria will be there in one day. Okay. And then in D, we want how long does it take for the culture to triple in size. That means it will be 3 times the starting population of the bacteria, of course. All right. So let's do A first. A says the recursive formula. Okay. So what's the recursive formula for the exponential growth? Who wants to volunteer this answer? Just a quick reminder, you need to remember these formulas. These will not be given in your exam. So you need to remember what does this formula look like. So what's the general recursive formula for the exponential growth? Let's say not for this one. What's the general one for the exponential growth? No one? Just give it a try. The general one, I'm not talking about this problem. The general recursive formula for the exponential growth.
The formula is P of n equals 1 plus r times P of n minus 0.
N minus 0?
Sorry, minus 1.
Very good. N minus 1, yeah, definitely. This is the general recursive formula for the exponential growth. Okay, now we want to see what, or rather how this formula would look like for our given data set. So for that, we want to understand what are these? What is this 300? What does this mean? What is this 4 hours? And how can we use this 500? So we want to know what does this mean. So what's 300? Let's do it one by one. How can we denote it? What does this signify? Anyone? That should be a pretty straightforward one. We started with this number of bacteria. So what it should be?
P0.
P0, exactly. So it's the initial population. It's P0, right? What's 4 hours here? Or rather, how can we use this information? Is this important for our problem, or it could be something extra? We may or may not need this. Sometimes in maths, we try to confuse students with some extra informations, which they don't really need. Is this important? Do we need this?
Is that the R?
So R is always the growth rate. This looks like a time interval, right? Time duration. This looks like a time duration. It can't be R. R is definitely a rate. Anyone else? Even if you're wrong, just give it a try, because for the exam, you need to understand this, right? You need to understand what does the information mean,
It can be used to find R.
and how.
You take 500 and you divide it by 4 hours.
Only like this. You're almost right, almost, not quite. Anyone else? We just need a slight, a really, really smallish correction here. It's almost right though. Again, that's why I'm saying over and over and again, Jane, that um, you need to understand how can you use this given data set, or how can you use these informations. So R is the rate, right? Now, what do you understand by rate? That means you're trying to find a value per unit time. So we're looking for a value for a change. It could be increasement, it could be a decreasement, doesn't matter. We are looking for a change per unit time. I'm sorry, I've already used per here. So per unit time. Now can we eyeball this and find R from these informations? It's a tricky one though. Yeah, I think it's a good choice. Very good question. Uh, Whoever picked it, I'm sorry I couldn't see your name, but it's a very good question. Yeah. So as we're looking for the rate, that means we can use this way. So initially, when n equals 0, our population was 300. And when n is 4, our population is 500. So the change is 500 minus 300. That's the change, by the way. That's not the rate. And how many hours did it take to make this change happen? Can you see that? Anyone?
4 hours.
4 hours. And as I said, rate is basically the change per unit time. So what should you do?
Divide that by 4.
Very good. Excellent. So that means, since we are trying to find it for per unit time, that means what happens per hour. That means we want to divide it by 4, because the change was actually made in 4 hours, but we are looking to find it. We're looking what happens uh, per hour. What happens if we just consider 1 hour? That's the unit time, right? Here, because we are uh, considering the time duration in hours. So if we divide it, yeah, so sorry, go for
That's
it.
okay. I divided it.
Okay, so what's the value?
I got 50.
50?
Mhm.
Okay, let me see. So it's 200. Yeah, it should be 50, right? 50. Yeah. So that should be your R. Okay. but we still need to do um, just a little bit modification to this, because if you remember, we used percentage for R, right? If you remember, R was a percentage. We wanted to use it for this percentage means we're calculating it for per 100 units of whatever the population is. For this time, for this problem, our population is for bacteria. So we want to convert it for per 100 bacteria. So that should be our R. Okay. So this change was made for 300. For 300, the change per hour was 50. So for 100, it would be 50 times 100 over 300. So it should be 50 over 3 rather. So if we divide it, I guess it should be 16.66, I believe. Let me see. 50 divided by 3. Yeah, 16.67%. So this should be our R. Okay. Now we know that the formula is Pn equals to 1 plus R times Pn minus 1, if I'm not wrong. Is it? Yeah. Okay. So for this problem, our formula will look like, so Pn is 1 plus, so R in decimals would be 0.1667. So you might say 0.167, or if you want, you can keep it up to 4 decimals, or 3 decimals rather. 4 or 3 decimals at most. You don't need to take more than that. Times Pn minus 1. So it should be 1.1667 times Pn minus 1. So this should be your recursive formula for the exponential model. Okay. If you have a question like this, this will be actually given. There will be a gap like this. I think you've seen a problem like this in your homework. So there will be a box or a place where you can write your answer, and you'll have times Pn minus 1. That means you just need to write this one. Okay. If you have a question like this, of course. All right, let's see B. B is excuse me. B is, what is the question again? Write the explicit formula for the number of bacteria. Okay. So what's the general formula again? Once again, we'll start from the very beginning. What's the general formula of the exponential model? What's the general explicit formula I'm talking about?
So P sub n equals 1 plus R to the power of n times P sub 0.
Like this?
Yeah.
Okay, so if we have, if we already know, or if we have the formula, now we can actually plug in the values to get the explicit formula for this particular problem, right? So we know P naught is 300 because it's the initial population which is given. And we also know R, so it will be 1 plus 0.1667 power n times 300. Or we can rewrite it like this, 1.1667 times 300. So this should be our explicit formula. Okay. All right. Let's see question C. Question C says, what is that question? Okay. If this trend continues, how many bacteria will there be in one day? Okay, so that's a tricky question again. So definitely would like to use the explicit formula because it's more convenient. Unless otherwise mentioned, we'll always use the explicit formula to calculate our population. It's much easier to use, okay? All right, so now it says find it for one day. I mean, what happens, literally it means what happens after day one. How many bacteria will there be if the bacteria keeps growing? Where is that rate again? Here it is. Keeps growing by 16.67% per hour, of course.
Professor, I think I know what to do.
Okay, go for it.
So we would use the explicit formula and you would plug in 24 for n because they use hours in the problem. And so we would have to convert one day into how many hours that is.
Brilliant. Yep, absolutely.
So then it would just be 1 plus 0.1667 to the 24th power times 300.
Very good. So I think I can use 1.667. So if you're wondering what happened here, let me just write it first and then I'll explain. Our time duration is given in hours, right? It's not really given in days or in months or in years. It's given in hours. We know this R, whatever the percentage is actually for per hour. And this 300, we actually calculated it for hour as well. It's not, excuse me, it's not giving us any data for a day or even for a bigger time duration. All of these are considered for a time duration for an hour, right? So definitely we need to convert this one day to hour first. So one day we know it's 24 hours, right? So that means our n will be 24. So we have plugged in. Last night I received my second dose of Pfizer. Oh, okay. I guess he has some reason to be absent today. Anyway, so our n is rather 24. So I plugged in 24 in place of n. Excuse me. And now if we calculate, we should get our result. But before we calculate, any question, because this is slightly tricky. You need to convert the time duration to the exact one which is given. The question asks you to solve it for one day, but your data set was for hours. So you need to convert either way. At least, I guess the most convenient way is to convert your day to hours because you have already calculated everything for hours. So it's easier to convert this. You can also convert in the opposite way as well. You can convert your hours to day. So this should give you the same result as well, whichever you like. So any question before we calculate it finally? Any question? No questions at all? Okay, so if you use your calculator, you should get this 1237.86. I've taken 2 decimals, 2 points after decimal. So this is the number of bacteria you will have if the rate uh, is maintained throughout the day. Okay, as the question says, if this trend continues, so after day one, we'll have 12,137. Or if we round it to the nearest integer or the whole number, it should be 12,138. Okay. Now, any question from this? Any question? Anyone?
For the exam, how are you going to expect rounding to be done?
Excuse me. Yeah, that's a good question. So when I set up the question, I actually set up the tolerance level as well. So if you have, let's say, 12.583215.6, let's say if you have a value like this on your calculator, just take up to 3 decimals. Okay, since it's a population, we'll try to round it to the nearest whole number, right? So if you do this and round it to the nearest whole number, you'll get full credit for it. Okay. You don't need to even write it in decimals. You can just straight away write the nearest whole number. Yeah, you'll have a question like this where you need to round it to the nearest whole number. So yeah, that's a good question. But as long as you are rounding it in the right way, I mean, if it's more than or greater or equal to half, then you need to go for the next integer, next whole number. If it's less than half, then you need to go to the previous whole number. So for example, if you have something like this, 583, if I take up to 3 decimals, it's definitely more than 0.5, right? After the decimal I'm talking about. So I'll write 13 instead of this. All right. Excuse me. Okay. Anything else from this problem? We still need to do problem D though, but up to C. If you have any question, you can ask. Anyone, any question? No questions at all? Okay, let's move to D then. D says, again, if this trend continues, how long will it take the population to grow to get triple in size? Okay, so it will be 3 times the initial one. So first of all, your job is to understand what does the question wants you to do. Can you interpret it using English words, in easier English words. Can you rephrase this so that anyone who is not in a math, who doesn't really live in a math society, can still understand what the question wants you to do? Can you rephrase it? Using the data set you have. Anyone?
I mean, it's kind of the same thing, but like, how many hours would it take for the population to grow to 3 times its normal size?
So we're looking for n, right? We want to calculate n. And our initial population was 300. So we're looking to find how long will it take to reach 900. Is
Do
the
we
sorry? Yeah.
do we set up the explicit form to be equal to 900?
Yeah, I'll come to that. Yeah, yeah, you're right. But yeah, I'll come to that. But first of all, is the question clear? We want the population to reach 900. And for that, we want to calculate the time duration. How long does it take, right? That means we're looking for n. Is this clear to everyone? Does this make sense? Because if it doesn't make sense, then you need to clarify this first. Okay, if you have any doubts, I'm more than happy to rediscuss this again. But make sure, just ensure that these are really, really clear and transparent to you. Excuse me. No questions? Perfect. Let's move on then. So, yeah, you're right. So we'll move, or rather, we'll set up. It's not 300. It should be 900. Yeah, it should be 900. Our PN should be 900. We know the final population. We know the rate. We're looking for the time, so n will be n times 300. So that's the explicit formula. And we have plugged in the values to set up the equation. Is there any question on how did we set up the equation? It could be tricky. Anyone? All good? Very good. So now let's solve it. Again, we have solved problems like this many a times before. What should you do? We're looking for n, by the way, if you remember. What should you do? What's the first thing comes into your mind when you see an equation like this?
Well, I wanted to divide it by 300, but using the order of operations, shouldn't we get rid of the exponent?
So if you want to get rid of the exponent, that means somehow or other, we want to isolate this unknown n, right?
Right.
So if you want to get rid of this, yeah, you're right. We need to first divide both sides by 300.
Okay.
Because our first job is to isolate the term with n. We can't really isolate n straight away because we have some additional things with it, right? So the first job is to isolate the term with n. So that means we'll try to isolate this guy first. And to isolate that, if we just divide both sides by 300, you can see this can be isolated, right? Excuse me. So let's do that. if we divide both sides by 300, on our left, we should have 3. And on our right, we should have just 1.1667 to the n. Someone has entered the lecture. I guess he is too early for the next one. Anyway. All right. So we have isolated that. Now we want to get rid of this exponent. We not only we want to get rid of it, we actually want to find the value for it, find the value of it rather. Now what should we do? What's the next thing we need to do?
Divide by 3.
If we divide by 3, let's see what happens. So on our left, it will be 1. On our right, it will be this. I don't think this helps. So this doesn't look the right approach. Anyway, thank you for trying that. It's okay, even though it's wrong. So what should we do then? Dividing by 3 doesn't really work. Anyone? Because you'll need these techniques for the exam, right? It's really, really important. Yeah, go for it.
You need to take the log on both sides.
Exactly. When we have an exponent and we want to get rid of it or we want to solve it, then we use logarithm. Okay, so let's take excuse me, log on both sides. So log 1.1667. And if you're wondering why are you doing this, the reason behind this is we know if we have anything like this, we can write the exponent in front. That's the property of log. That's the logarithmic property. We can write this exponent in front. And this way you can see we can actually isolate this pretty easily. Excuse me. So let's do that. Let's use this property. So on our left, it will be still log 3. What should be on our right? What should we have? If we use this property, what should we have here?
N log of 1.1667.
Very good. So the exponent will come in front like this, and the rest will remain as it was. Okay. We have done the hard work, but we are not quite there. We don't have our desired result. We're looking for the n. We're looking for this. We're trying to find the value of n. Now what should we do? What's the next thing which can help us to
Find the value, sorry, find the value of log 3 and log of 1.1667.
Yeah, we can do that, but we're looking for n. It's not yet isolated.
The way I did it, I found the volume or the value of those two, and then I divided by n.
Divided by n?
I divided, sorry, no, I divided by the value of log of 1.1667.
Exactly, yeah, right. So what we'll do, as we're trying to isolate this n, so we can just divide both sides, sorry. We can just divide both sides by this, and it will isolate our n. Can you see that? So if we do that, we'll have log 3 over log 1.1667 excuse me, equals to n. We have successfully isolated this. That's what we wanted, right? So if we use our calculator, it should give our desired result. So let's check. I'm doing it myself, and you can check your work as well. You can cross-check your work with me. So use your calculator to divide log 3 by log of 1.1667. So if I divide this, my calculator gives me 7.12. I take up to 3 decimals. It's 6. Is there anyone who has a different result? Or is it the right answer?
Yeah, that's what I got.
Okay, cool. So if you use a calculator, you should get this. Now, if we round it to the next, or not, I should not say next, to the nearest whole number, excuse me, what it should be?
7.
7. Very good. It's definitely less than half, right? Less than 0.5. So we can say, after all this discussion, that after 7 hours, the bacteria in that particular culture will be not, that means we'll have 900 bacteria after 7 hours. This is the answer. Excuse me. I'm sorry, I'm just a little bit sick today, so you can see some interactions every now and then. I'm sorry for that. Anyway, any question from this problem? Exercise 11. Any question? If you want me to rediscuss anything, I'm more than happy to do that. Excuse me. Anyone, any question?
For a problem like this, is it not quicker to mess around with the value of n to find 900?
Did you mean that you can plug in different values of n and check?
Exactly.
Okay, so yeah, that's that's a clever option to have, to be honest, but that could be time consuming as well. What if I have said, how long will it take to reach 2,000 bacteria? Then your n could be, I guess, around 15. So it will take much more time than if you just calculate it. What if I say 20,000, right? So if it's big enough, then that trial and error, in maths we say trial and error. That means plug in the value and check whether it satisfies or not. That's actually a clever option, but only if it's a really small a value to calculate. If it's a big one, then it might take you. It really will take a lot of time. That won't be a clever option then. Okay. Instead, if you know this technique, how big this value is doesn't really matter. It will still take this amount of steps and the same amount, literally the same amount of time as well. How big the population is doesn't really matter. Excuse me. Any other questions? Anything you want me to rediscuss from this? Because we have discussed this technique probably after 2 weeks. So things might look new to you, but we definitely have discussed and solved this type of problems many a times, at least 5 to 6 times. You have the lecture videos on YouTube. You can find it on the announcements. And if you go back to the previous lectures, when you started growth models, you'll see lots of problems were done where we needed to use this technique. Okay, if you review those materials, I guess you'll remember this and things will make more sense. Any other concerns about the exam? Anything you want me to clarify, maybe? Because I don't think we have enough time to solve any more problem. Maybe a really, really smallish one. If you have, I guess 12 is pretty similar. So if you can understand 11, you should be able to do 12 as well. If you can't, just email me. I'll do it for you. Is there any other smallish problem which you can do within this 5 minutes or so? Or any techniques you want me to rediscuss maybe?